Hi everyone, welcome to the Dynamic Maths channel. Today we are going to learn about quadratic functions. I highly recommend that you should watch a guide to quadratic equations before watching this, as it will help you understand this video better. The link is given in the description below. Quadratic functions are more graphical rather than analytical, as we will focus more on sketching rather than solving it. Let's get started. Firstly, we will discuss about the shape of a quadratic function, which is fx equals ax squared plus bx plus c. A quadratic function gives a parabolic curve when plotted on a graph. It can be a positive curve or a negative curve. To determine whether it is a positive curve or not, we had to look at the value of a in the general equation. If the value of a is positive, it will give a positive curve or a smile. Remember, a positive person always smiles. When a is negative, it will give a negative curve or a frown, just as a negative person is always frowning. Here is an example on how we will determine whether the parabolic curve is negative or positive. Here I have an equation x squared plus plus 3x plus 2. We will now determine whether the curve is positive or negative. First, we look at the value of a. In this case, it is positive 1. Therefore, your curve will be positive. Next, we will discuss about the intersection of the quadratic function with the x-axis. This is important as it can help to sketch the parabolic curve later. The intersection of the function and the x-axis is called a root of a function. As mentioned in the quadratic equation video, there are three types of roots for a quadratic function, which are two real roots, two equal roots, and no real roots. This can be determined by using the test b squared minus 4ac. Use this relationship to determine the types of roots of a function. Here are some examples to determine the nature of roots and the shape of the curve. Here, let's look at the first question, where fx equals x squared plus 3x minus 2. We will use the test b squared minus 4ac to determine the nature of roots. Substitute the values accordingly and solve. Here, the test is 17, which is more than 0. Therefore, it concludes that the shape has two roots. Therefore, we sketch the curve where a is more than 0. It is a positive curve. Because it has two real roots, the x-axis crosses 2 points. Let's move on to the second example. In the same just as the previous example, we'll use the same test. Substitute the values accordingly. And solve. Here, the value of the test is 0, which means that it has two equal roots. When you sketch the curve, you will notice that it only has one intersection at the x-axis. To do this, we look at the value of a and we find that it is a negative number. Therefore, our curve is negative. And because it passes through the x-axis only once, it will pass only through the tip of the curve. Now let's move on to the third question. In the third question, we use the same test again. We will get negative 24, which is less than 0. Therefore, which means it doesn't have any real roots. When you sketch this curve, you'll notice that it is a positive curve. But when it comes to the x-axis, it doesn't cross to any point of the curve because it does not have any real roots. Therefore, it doesn't cross. Here are the three applications of the test, and you notice that the curve will cross to 2 points, a single point, and no point. Every quadratic function has a minimum or maximum point. To obtain this, we need to learn how to convert the quadratic function from the general form to the completed square form. Here's how to do it. First, we write down the general equation. Then, we factorize a from the x squared term and the x term. Then we introduce this term into the equation. If we introduce this term, we have to add this term and minus the same term, which will be then we can then factorize these three terms to give us we then remove this term from the bracket to give us because A, B, C are numbers, we can combine them into a single term, single variable. We can combine this as p, and we can combine this whole term as q. Therefore, your function will be which is the same as the answer over here. To determine the minimum and maximum point, we need to take this term and this term into consideration. When you equate x plus p equals 0, you will get the x coordinate of the minimum or maximum point, which will be minus p. To get the y coordinate of the minimum or maximum point, you just have to equate it to q. Therefore, when you draw your curve, the minimum or maximum point will be minus p and q, and over here will be minus p and q, depending on the equation. To sketch a proper quadratic function, we need to know these four variables, which is the shape of the curve, whether it is smiling or frowning, the nature of the roots, we have three types of roots, the minimum or maximum point, which is determined by the shape of the curve, and then the roots and the intercept of the quadratic function. After knowing all these four, we can sketch a proper function. Here's an example on how to sketch a quadratic function. I will draw a segment over here to show our sketch. Firstly, we have to determine the shape of a quadratic function. Since the value of a is positive, the sketch has a positive curve. This part is a piece of cake. The next step is to find the nature of roots. We'll use the test to find out. B squared minus 4ac. The test shows that it has two real roots. Therefore, we can draw the x-axis across the curve. It has 2 points of intersection. After that, we find the roots of the quadratic function. We will use the quadratic formula to solve the roots. The roots are minus 1 and minus 5. We can now mark it in our sketch. Then we will find the y-intercept. We can substitute x equals 0 into the function to get y. Mark the y-intercept after calculating. Last but not least, we need to determine the minimum point of the quadratic curve. Convert the current equation into its completed square form. Luckily for us, we have derived the value of p and q, and we can use this to our advantage. If you went back a few minutes ago, when I was converting the general form into its completed square form, the formula for p is and the formula for q is then we substitute the values of a, b and c with the values from the general equation. To get the minimum point, we just need to solve for x equals to minus p and y equals to q, which gives us minus 3 and minus 4. This is the minimum point, and the coordinates of this point is minus 3, minus 4. This is how you sketch a quadratic function. There are several steps involved, but through repetition, you can memorize and understand the concept of sketching quadratic functions, as practice makes perfect. In conclusion, we have learned about the shape of the quadratic curve, the nature of roots and its graphical representation, and the minimum or maximum point of the quadratic curve. This topic is more graphical than analytical, but it is fun to sketch once you get the hang of it. If you found this video to be useful, share it with your friends and family. Don't forget to like and subscribe, and I'll see you in the next video.